Now that we've reviewed emergency procedures, it's important to be able to recognise the difference between routine opening problems and real malfunctions. There are two categories of malfunctions: low speed and high speed. Low speed malfunctions occur when the canopy has 5 or more cells open. Your vertical descent rate will be dramatically reduced, and you may have some limited time to assess the situation, decide and act. This compares to high-speed malfunctions where you may be travelling at terminal velocity with very little time to act. Let's look at the causes, effects and remedies for low-speed malfunctions.
Any unusual deployment may cause uneven tension on the suspension lines, resulting in tension knots or a stabiliser hanger. Once again, the need for stability on deployment is critical. Tension knots will affect the symmetry of the canopy, resulting in it having a higher rate of descent and the canopy rotating rapidly, causing centrifugal force. The remedy for tension knots is to grasp the toggles and smoothly perform 2 full flares. This will stop the turn and slow the canopy down. Maintain height awareness and be prepared to initiate emergency procedures by 2,000 feet. Maintaining height awareness is critical in all malfunction scenarios. You must make a decision by 2,000 feet. And commit to either cutting away or landing it. Out-of-sequence deployments can cause line-over malfunctions. Once again, the need for stability on deployment is critical. In effect, you would expect a low rate of descent, possible canopy rotations, and lack of controllability. The remedy for a line-over malfunction is to grasp the toggles and smoothly perform 2 full flares. This may allow the line to clear the canopy. Maintain height awareness and be prepared to initiate emergency procedures by 2,000 feet.
I think it can really help us with our confidence to actually go through a malfunction at some stage and have to go through our emergency procedures. It gives us lots of confidence in our equipment, gives us lots of confidence in our abilities and faith in our training and faith in ourselves.
Unusual forces on deploying canopies can be caused by a head-down or unstable deployment. Age and sun damage can also contribute to the strength of the canopy. The effect of the tears or holes in the canopy may create an unusual shape which may be uncontrollable. The remedy for a damaged canopy is to initiate emergency procedures by 2,000 feet. Broken lines can be caused by an unstable deployment which exerts unusual forces on the lines. Line strength also deteriorates with age and exposure to sunlight. The effect on the canopy may be an unusual shape, it may be uncontrollable, and broken lines may be hanging below you. The remedy is to conduct a controllability check. Locate your toggles, do 2 full flares, a left turn, a right turn, and if it's still uncontrollable, initiate your emergency procedures by 2,000 feet. A pilot chute over the nose can be caused by a fast, sharp opening. The effect is that the canopy may stall when flaring and may have limited steering. The remedy for a pilot chute over the nose is to carry out your controllability checks. Grasp your toggles, conduct 2 full flares and left and right turns. If the canopy exhibits poor handling, be prepared to carry out your emergency procedures before 2,000 feet. A jam brake can be caused by the excess brake line becoming dislodged and entangled during deployment. The effect is limited steering ability since one brake is locked in position while the other can move freely into either full drive or the full flare position. The remedy is to make 2 attempts to free it. If unsuccessful, initiate emergency procedures by 2,000 feet.